This problem is related to the concept of pressure inside a soap bubble. And problem says a spherical soap bubble inside an air chamber at pressure P naught, which is equals to 10 to the power 5 Pascal, has a certain radius, so that the excess pressure inside the bubble is delta P, which is equals to 144 Pascal. So we have this air chamber, and inside this chamber we have a soap bubble. Pressure inside this air chamber is P naught, and excess pressure inside the soap bubble, this is equals to delta P. Now the chamber pressure is reduced to 8 P naught by 27, so that the bubble radius and its excess pressure change. So now the pressure inside this chamber is reduced, and that is why this bubble has expanded. Let us say it will have a different radius. Basically this will have an increased radius from the earlier situation. In this process, all the temperature remain unchanged. So initial temperature is equals to final temperature. So this means we can apply isothermal process equation. It also says assume air to be an ideal gas and excess pressure delta P in both the cases to be much smaller than the chamber pressure. So this is an ideal gas situation. So we can apply PV is equals to nRT. But the temperature is constant. So we can apply P1 V1 is equals to P2 V2. It is also given that excess pressure is smaller than the chamber pressure. So this means if I have delta P plus with P, then I can approximate this equal to P. So we have to find the new excess pressure delta P in Pascal. So what is the new excess pressure inside this bubble? So let us try to solve this problem. So what are the things that is given initially? So you have been given chamber pressure, that is P naught. Let us say radius of this bubble is R1, and excess pressure inside this bubble that is given, that is equals to delta P, and let us call this as a delta P1, and this is equals to 144 Pascal. Now after the chamber pressure has reduced, that is 8 P naught by 27, let us say radius is R2, and excess pressure inside this bubble is delta P2. Now we have this equation. If you remember this equation, that is there is a relationship between excess pressure, chamber pressure and surface tension, and this equation is this, that is excess pressure plus, that is excess pressure is 4S by R. Excess pressure plus chamber pressure is equals to pressure inside the bubble. So we can write here, let us say pressure inside the bubble is P1, then this will be equal to chamber pressure P naught plus 4S by R, that is excess pressure which is coming due to the surface tension. And this value is 4S by R1 because in this case radius is R1. We can also find volume of this bubble. In this case this is a spherical, so this will be 4 by 3 pi R1 cube. So initially we know P1 and V1. Now once I expand this, or once we reduce the chamber pressure, now P2, that is pressure inside this bubble, will be chamber pressure, that is 8 P naught by 27 plus excess pressure, that is 4S by R2, because radius is R2. What is volume? Volume will be 4 by 3 pi R2 cube, because now in this case radius is R2. So now what are the things that we know? We know P1, we know V1, and after we know P2 and V2. So we can apply P1 V1 is equals to P2 V2 because this is an isothermal process, temperature is constant, this means nRT is constant, so we can apply P1 V1 is equals to P2 V2. So this is P1, this is V1 and this is P2 and this is V2. Now if you remember, we said in the beginning that is excess pressure is much smaller than the chamber pressure. Similarly here also this excess pressure is much smaller than this chamber pressure. So we can ignore this term and we can ignore this term while adding. So we can say that P0 is much greater than 4s by R1 and at P0 by 27 is much greater than 4s by R2. So we can ignore these two terms and we can simply write like this. So this pi will cancel, P0 will cancel and we can write R1Q equals to 8 by 27 R2Q because 4 by 3 will also cancel. So R1Q is equals to 8 by 27 R2Q and 8 by 27 is nothing but 2 by 3 into 2 by 3 into 2 by 3. So this means R1 is equals to 2 by 3 R2. So we can basically write this equation and if we want we can write R1 equals to 2 by 3 R2. So we got one equation. Now let us find another equation. So we know delta P1 that is given 144 Pascal and this is equals to 4s by R1. Similarly I can write after that is delta P2, this will also be equals to 4s by R2. Now if I divide this equation and this equation, so I will have delta P1 divided by delta P2 and this is 4s by R1 divided by 4s by R2. So now 4s will cancel, so I will have delta P1 by delta P2 and this is equals to R2 by R1. So this is my equation 2. So I know the ratio of R1 R2 from here and I know delta P1, then I can calculate delta P2. So let us try to solve this. So from equation 1 and 2, so this is my equation 1, I can also write R1 by R2 Q equals to 8 by 27 and this is R1 by R2 is basically delta P2 by P1. So I can plug this value here. So delta P2 by delta P1 Q equals to 8 by 27 and this is 2 by 3 into 2 by 3 into 2 by 3. So delta P2 by delta P1 is equals to 2 by 3. So this means delta P2 is equals to 2/3 of delta P1 and initially we know the excess pressure delta P1 is 144 Pascal. So this means 144 times 2/3, that is basically 96 Pascal. So the excess pressure inside this bubble after reducing the chamber pressure is equals to 96 Pascal. So I hope you enjoyed this problem and if you like my videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.